Welcome to this Forge College Explainer. First off, wow, a massive congratulations to you. If you're tuning in right now, it means you've successfully wrapped up the final integration and capstone submission from our last lesson. You actually built and deployed a working piece of Solana architecture. That's literally no small feat. Seriously, great job. All right, let's just dive right into this next module. Today we're taking a blueprint tour, a complete overview of Solana program templates.
So you've deployed a capstone, right? You've taken the car for a spin, but what exactly is going on under the hood? Because, it's one thing to drive the car. It's an entirely different beast to pop that hood open, understand the wiring, and know exactly how the engine components talk to each other without short-circuiting the whole system. To safely modify and extend your on-chain logic, we really need to transition from just using templates to truly understanding their structural DNA.
So here's our blueprint legend for today's explainer. We're going to hit the anatomy of a template, look at the machine mental model, take a quick tour of the core files, go through the rapid navigation workflow, and wrap up with some key blueprint takeaways. Don't worry if complex architecture usually makes your eyes glaze over, we're going to break it all down.
All right, Section 1, the anatomy of a template, the blueprint. At its core, what actually is a Solana program template? Simply put, it's a highly organized collection of Rust code, build configurations, and metadata. But it's absolutely not just arbitrary folders. This structure dictates exactly how your program behaves on-chain.
Now, right off the bat, notice our old friend here, BorshDeserialization. Remember that the blockchain basically just reads raw streams of bytes, right? Well, BorshDeserialization acts as this vital mechanical conveyor belt, moving all that data through your template structures. It's what shapes those raw bytes into concrete Rust structs and enums for your accounts and instructions. You've got to always keep Borsh in the back of your mind when looking at these templates, because changing how that conveyor belt is packed, that directly impacts your program's survival on-chain.
Moving on to Section 2, the machine mental model, compartments. Instead of just seeing a bunch of text files, I want you to start anthropomorphizing your template. Imagine it as this quirky, physical machine sitting right there on a workbench, divided into 4 distinct operational compartments. Here is our machine. First, we've got the input compartment. These are your instruction definitions and deserialization logic. This is where those raw bytes first arrive. Next up is the control compartment. Think of this as like an over-caffeinated traffic cop, right? Decoding the input and frantically waving instructions toward the exact right handlers. That is your processor. Then we have the data shelves. Think of this as an aggressively organized pantry where your account state lives. It's where the unpacking, packing, and validation all happen. And finally, the external connector. These are your cross-program invocation helpers, or CPIs, which basically allow your machine to plug into and talk to other programs on the network. So, input, control, data shelves, external connector. Lock that image in your head.
Okay, Section 3, touring the core files, wiring the machine. Now that we have our theoretical machine parts mapped out, it's time to actually look at the Rust files that make up this real-world schematic. Let's connect these abstract ideas to what you'll actually see in your code editor. Let's systematically map this out, starting right at the top. src/lib.rs is your crate root. It wires all the modules together and exports the program entry point. Then you've got src/processor.rs. That's your control compartment. It holds the dispatch logic, inspecting an instruction, and calling the matching handler. Next, src/instruction.rs. That's your input compartment, defining the enums and Borsh serialization for payloads. Down below that, src/state.rs, or sometimes you'll see it called accounts.rs, acts as your data shelves, holding the structs and packing helpers. And finally, Cargo.toml. This is your build manifest, controlling the compiler flags and dependencies that actually shape your final binary. If you know this structure, you know the machine. Simple as that.
So the absolutely crucial point here is the program entry point, usually found right there in lib.rs. This is the initial loading dock of our machine. It's basically an adapter wrapper. It is not where the heavy business logic lives. Instead, it takes the raw instruction data array and the account info references handed over by the Solana runtime and just passes them into our organized little factory for processing. It's the gateway.
Now, there is a magic number when it comes to safely modifying this machine, and that number is 4. There are exactly 4 sequential steps you must follow when you want to evolve your program's API or add a new instruction. First, you update the instruction definition. Second, update the processor dispatch to handle it. Third, update the account state to match. And fourth, run your build validations and unit tests. Instruction, dispatch, state, build. Miss even one of these and yep, the machine jams.
And I really cannot emphasize this warning enough. Changing field order equals breaking the on-chain ABI. Seriously. Because Borsch serialization relies on the exact order and types of your fields to pack and unpack bytes. If you just go into state.rs and swap two fields around without a proper migration strategy, you're going to immediately break the machine's wiring. The runtime will read the bytes incorrectly and your program will crash. End of story. Always respect the ABI. All right, on to Section 4, the Rapid Navigation Workflow Assembly Manual. We've talked about what the files do, but what happens when you're dropped into a completely unfamiliar code base? You need an assembly manual so you can read it without, completely panicking.
Look, we've all been there. The bad workflow is staring blankly at a new GitHub repository, clicking into every single file top to bottom, scrolling in a cold sweat and just hoping something makes sense. The good workflow is what we're teaching today. The Machine Mental Model Checklist. It's a methodical, targeted strike on the codebase to extract exactly what you need in minutes, not hours.
Here's your 7-step checklist. Step 1. Directory scan. Just look at the top-level folders. Is there a tests directory, client code? Step 2. Find the entry point. Pop open lib.rs, find the macro or adapter, and see exactly how those bytes enter. Step 3. Read the instructions. Jump to instruction.rs to see the program's surface API. Like, what can this program actually do? Step 4. Map the handlers. Look in the processor to see which function handles which instruction. Step 5. Inspect the accounts. Check state.rs for those Borsch drives and see how the data shelves are built. Step 6. Check the manifest. Peek at Cargo.toml for any weird dependencies or feature flags. And finally, Step 7. Local static checks. Run a quick compile. Follow these 7 steps every single time, and I promise you will never be lost in a Solana repo again.
Okay, bringing it all home with Section 5. Key Blueprint Takeaways. Final Inspection. Let's just do a quick final inspection before we let you loose to start heavily modifying or deploying new code.
If you remember only one thing from today, let it be this golden rule. Treat instruction enums and account structs as the program's external API. Your Rust code on Solana is a highly predictable machine. Changing its outward shape, the way those structs and enums are physically ordered, must be done with the utmost care, because the rest of the blockchain interacts with you based strictly on that exact shape.
So we know where things happen, but how exactly do those raw, confusing instruction bytes magically become perfectly typed arguments inside a handler function? Well, that's exactly the mystery we're going to unravel in our next lesson, Program Entry Points in Practice. You definitely won't want to miss it. Thank you so much for joining me for this Forge College Explainer. To learn more about this subject, dive into more Web3-related topics, and to continue your development journey, be sure to visit us at forge.college. I'll see you in the next one.